Hello students, so far in all the previous videos I have explained about natural numbers, prime numbers, composite numbers. Also have explained about the fundamental theorem of arithmetic. Okay, so all these things are related to chapter 1, real numbers. Okay, so after having finished explaining all the terms which are needed for the next exercise, so let us move on to the exercise then. So you can see here there's the exercise 1C which we are about to start, and we'll straight away start with slab 1, question number 1. And the question number 1 here is find the prime factorization of the following numbers. That means these are all composite numbers, means they all have more than 2 factors, and you have to prime factorize them. Means you have to find the prime factors of this number. That means we have to apply here the fundamental theorem of arithmetic, which says that any composite number can be decomposed or expressed as the product of prime numbers. So first of all, you should know all the prime numbers. It should be by heart to you. So here's the list. I've already explained about prime numbers also to you students. So first of all, say these are all prime numbers. That means what? When you do prime factorization, we should divide only by these prime numbers. You're not allowed to divide by any other number, but only by prime numbers. And moreover, it is always better that if you start, when you find prime factorization, you start with 2 first. Means what? If the number is divisible by 2, the first one prime number 2, then you divide by 2. And if you cannot divide it by 2 anymore, then you go to next prime number, that is 3. And if you cannot and if you can divide by 3, you divide it, and if you cannot divide it further, then you divide by 5, and so on. Like this, you should try by 7, 11, 13, 17, like this, and so on. So you have to memorize all these prime numbers. Okay, one thing I want to tell you, that while doing prime factorization, if any prime number comes, then no need to waste time, because the prime number, when you get prime number in while prime factorization, that prime number should be divided by itself, because as you know, a prime number is divisible by 1 or by itself. So there's no question of dividing by 1, because 1 is not a prime number. We are finding prime factorization, that's why you have to divide by itself. Okay, but suppose I give you a number. Okay, yeah, say I've given you a number, and you want to divide that number by these prime numbers. Then it's always good to know the test of divisibility of some numbers, especially for these prime numbers, prime number 2, 3, and 5, because most of the times these numbers come and students always confuse whether these numbers are divisible by these prime numbers or not. Okay, so let me begin with the test of divisibility in this video. Okay, so test of divisibility, it means that we're going to do some kind of test before actual divide. We do some kind of test which can be done mentally, or your mathematical ability, with the help of mathematical ability. So these are just simple tests which will confirm that whether the given number which you have to do prime factorization is actually divisible by these prime numbers or not. Okay, so here comes. So first of all, we'll first see what is the test of divisibility of by 2. That means what? Suppose I give you a number, whether that number is divisible by 2 or not. Okay, how to check, how to confirm. Suppose I give you a number 4729. Now I want to do prime factorization, means I want to divide by 2. Can we divide this number by 2 or not? Means what? If I divide here and we find that it's not divisible, then it will waste my time. So before I divide, actually, we can do some kind of test on this number to confirm that whether it's divisible by 2 or not. If it is divisible by 2, then you move on, you carry on. Okay, you do the division. And if you cannot divide, then it's a waste of time. So don't divide by 2. And this way, we can do test for 3 and 5 and 7 also. So okay, other numbers also if it's there. So let's see how to divide, how to test by 2. Okay, so look, see how to divide a number by 2. So look, so please see this. A natural number is divisible by the prime number 2. See, a natural number is divisible by the prime number 2, this 2, if that number is an even number. That means what? If that number is an even number. Okay, that means what? If that number is an even number. If that number is even number, we can divide. It means all even numbers we can divide by 2. So it means that odd numbers are not divisible by 2. That means what? You have to judge. That means to know whether a number is divisible by 2 or not, you just have to look whether that number is an even number or odd number. But the question is about how to identify whether a number is even or odd, because we know that yes, even number we can divide by prime number 2. and odd number we cannot divide by prime number 2. But how to find out whether the given number is even or odd? Then it's very simple. Look, you have to go the definition of even number. Recall the definition of even number. You know that even numbers are those numbers which are divisible by 2, and the units place digit of even number are these. These are the units place. I think you know the place value: units, tens, hundreds, thousand. So the unit digit, the first digit should be one of these. 0, 2, 4, 3. One of these are there in the unit digit, and that number is even number. And since even number, it is divisible by 2. Even number is divisible by 2. Okay, prime number 2. Okay, but if that number happens to be odd, and see how to find out whether this number is odd or not, and these are the units placed in it. If the units places happens to be 1, 3, 5, 7, 9, then these are odd numbers. That means what? In the last example, I'll give you 4, 7, 2, 9. So look at the digit 9. Units, tens, 100,000. So the ninth place, so the units place is 9, and we can see here that 9 is an odd number. So since it's odd number, that means we cannot divide by 2. If I give you 376, then look at the unit places. Unit is 6. Units, tens, hundreds. So unit is 6, and see 6 is even number. Units places 6. It's even number, and even number we can divide by 2. So carry on, and here don't. Okay, because it's odd and it's even, so start with 2. So in this way we can save our time. Okay, because it'll help us to do faster. Okay, so this is the test of divisibility for 2. Now we'll see how to find out whether a number is divisible by 3 or not. Okay, suppose that a number is odd number. So odd means what? You cannot divide by 2, or even it's even, but you keep on dividing, then finally it becomes odd. A stage will come, the number changes to odd. Then see, odd number is cannot divide by 2, or the given number is not divisible by 2, then you should try by next prime number, that is 3. Okay, to find prime factorization. Because 3 is a prime number, so you should divide a prime number. But suppose the number is there. So before you do the actual divide, you can, for 3 also, you can check whether a number is divisible by 3 or not. And there's a test of divisibility by 3. Okay, so read. Look, let me read. A given number is divisible by 3 if the sum of the digits of the given number, that given number will have some digits like 0, 1, 2, 3, 4. So you add all the digits which is there in the number, sum of all the digits, and that sum, the total, if it is a multiple of 3, if the total is a multiple of 3, if the total whatever comes after adding all the digits of that number, if the total is a multiple of 3, means the total that comes after adding all the digits of that number, if that total is also present in the table of 3, then that number is divisible by 3. So let me explain you properly. Look, this example, with the help of example. Suppose I give you 441. Suppose I give you a number 441. Clearly 1 is odd number. 1, 1, 3, 5, 7, 9 is odd number. So odd number cannot divide by 2. So we are doing prime factorization. So by 2 we cannot divide because it's odd number. We should try by 3. Then try by 3. Don't divide directly by 3 because it's a big number. You'll say waste your time if it's not divisible. So you can test first. So you add all the digits of this number. 4 plus 4 plus 1. These are digits 4, 4, 1. So add all of the 4 plus 4 plus 1 is how much? 4 plus 5, 8 plus 1, 9. Since the total is 9, so the sum is 9. The sum is 9. Now this sum should be a multiple of 3. And yes, 3 1s are 3, 3 2s are 6, and 3 3s are 9. See, the sum here of 4 for 1 is 9, and this 9 is also a multiple of 3. In the table of 3, 9 comes. So yes, it's confirmed that this 441 you can divide by 3 because the total of this sum of the digits is a multiple of 3. Okay, so it comes in the table of 3. Suppose I give another example, say 263. Suppose I give another example, say 263. So 441 is divisible by 3 because 4 plus 4 plus 1 is 9, and 9 is a multiple of 3. 9 comes in table of 3. But same way, suppose I want to check whether this 263 we can divide by 3 or not, because see, 3 is odd number, we can divide by 2. So we should try by 3 next prime number. But we can divide or not. Don't, no, I said don't divide directly. Okay, first do the test. So what we'll do, we'll add this. See, here's the addition. Sum 2 plus 6 plus 3. 2 plus 6, 8. 8 plus 3, 11. Now quickly recall the table of 3. Does 11 come in the table of 3? Let's see. 3 into 1, 3. 3 into 6. 3 into 9. 3 into 3, 9. And 3 into 4, 12. 3 into 5, 15. 11 doesn't come in the table of 3. 11 is not a multiple of 3. So since 11 is not a multiple of 3, that's why 263 is not divisible by 3. That's why it's not divisible by 3, because the total is not coming in the table of 3. Okay, so understood now how to test for 3. So after you have learned the test of divisibility for 3, then you should learn for the next prime number, that is 5. How can a number be divided by 5? Okay, whether it's divisible or not. Okay, by the next prime number 5. So look, here's the test of divisibility for 5. So test of divisibility by 5. Look, a given number is divisible by the prime number 5. A given number is suppose a number is given to you. That number is divisible by the prime number 5 or not. There's a test. If its units place digit is either 0 or 5. That means what? You can divide any number. You can divide any number by 5 if the units place is, units, tens, hundreds, thousand, 10,000. This digit, units places, if it's either 0 or 5. Means what? No matter what, see, what digits you have here doesn't matter, but the units places or ones places should be one of these. It can be either 0 or 5. Then only you can divide by 5. So here's the rule. So see example, 2365. If you look very carefully, the unit places here is 5. Since the unit place is 5 here, therefore it is divisible by 5, because unit is 5. I told you a number is divisible by 5, its unit is either 0 or 5. And here, since it's 5, those divisible by 5. Here look, in the second example, 730. Suppose I give you a given number, say number 730, and you want to test whether this number you can divide by 500. Then it's simple. See, the unit is 0. And a number is divisible by 5 if the unit is either 0 or 5. So here the unit is 0, so it is 0 or 5. So yes, in this two example, these numbers are divisible by 5 because the unit digit is either 0 or 5. But see, in the third example, I've taken unit digit 7. It is neither 0, it is not 5. Therefore, it is not divisible by 5. Okay, so understood. So means we have learned 3 very important tests of divisibility of these numbers 2, 3, 5. What about 7? Actually, for 7, we don't have direct tests. Okay, so to confirm whether a number is divisible by 7 or not, you have to divide in the rough, or divide mentally, or divide somewhere. And then if you get remainder 0, then you continue, then you find prime factorization. If you don't get remainder 0, means what? That number is not divisible by the next prime number 7, so leave it. If remainder comes 0, you divide in the rough. As I said, the given number you divide in the rough by 7. If remainder comes 0, then divide by 7 in the prime factorization. And if it's not divisible by 7, then you go for 11. 11 there's a test, but this test is only for bigger numbers. That's why I suggest you that for 11 also, most of the time you just divide in the rough. If remainder comes 0, then you do that part by 11. If remainder don't come 0, then means it's not divisible by prime number 11. So then you have to move on to 13. Then in this way you try for all numbers by dividing, and if remainder comes 0, you do it in your copy in the sum. And if remainder comes 0, then leave the prime number. Then it's what? That prime number cannot divide. So go to next prime number. Okay. So in this way we find prime factorization of any given number. So first of all, I'm still telling you once again that you have to by heart all these prime numbers. Okay. If you don't remember these prime numbers, you'll really face difficulty while doing the sums, while solving the problems. Okay. Thank you so much.